Hello students, and welcome to the lecture on memory. After this lecture, we will be able to learn the following objectives. Explain the concept of memory and memory hierarchy. Define the main memory. Define the auxiliary memory. Explain the associative memory. Define the cache memory. Explain the virtual memory. The memory contains programs that are executed in the computer. The memory is a simple element, however, it has a great number of varieties, technologies, structures, services, and costs. Every computer has a hierarchy of memory elements, where some of them are internally located, while others are externally located. One uses memory to store the information, which includes both program and data. Due to several reasons, one has different kinds of memories. The memory of a computer is divided into two broad categories, internal and external. Internal memory is used by the CPU to perform tasks, and external memory is used to store bulk information, which includes large software and data. Memory is used to store the information in digital form. The memory hierarchy is given by register, cache memory, main memory, magnetic disk, removable media, magnetic tape.
When we perform calculations with a pen and paper, we often need to save intermediate results. And we may do this with, say, scrap paper. And in this case, the paper is acting as a form of external memory. And memory, no matter the form, takes up physical space. Computers contain memory. We can think of it as the scrap paper for the computer. And say when you construct an array to store values in your program, you require memory. And at the lowest level, computers read and store all instructions as a string of numbers. But how do you store numbers in a machine? This was a very difficult problem originally, especially when you need computers to hold their memory after the access to power is lost. This is known as non-volatile memory. The easiest difference for a machine to detect is simply a presence versus an absence of something. And this is how old punch cards would work. Along the top we have some data, and the vertical columns contain a series of punched holes which represent each character. So computers really have two fingers, base 2, same as a light switch being on for 1 and off for 0. This is the smallest amount of information, a single difference, which we call a bit. But bits are powerful for storage because the amount of unique states grows exponentially as we add bits together. Remember, one light switch is 1 bit and it can store 2 states. But 2 light switches can store 4 unique states. And 8 light switches, or 8 bits, can store 256 unique states. And space is measured in bits. But the physical size of a bit depends on your method of storage. So how do computers store zeros and ones internally?
Modern data processing systems like these use thousands of magnetic cores. What are magnetic cores? They are tiny rings of nickel alloy or other magnetic materials. They have replaced vacuum tubes for many important functions in data processing systems.
And it allowed computers to store bits as clockwise versus counterclockwise magnetization direction, because each core could be magnetized in 2 different ways, depending which direction the current was applied.
Because a bit can be represented by any bistable device, and a magnetic core is a bistable device.
Later on, This was done using thin film magnetic disk, where we can think of as each bit as a tiny magnetic cell which can be charged to store either a 1 or a 0. So long story short, the size of a bit has been rapidly shrinking since the days of punch cards. A hard drive in a modern computer can be thought of as billions of tiny magnetic cells. Now you may wonder, well, how small can these little magnetic cells be? And current research at IBM is pushing this to the atomic level, where they have shown 12 iron atoms can work together as a stable magnetic unit, where they're able to store a 1 or a 0 depending on how they're oriented. And this is approaching a theoretical limit where we would hold a single bit on a single atom.
Let's now discuss the concept of memory and memory hierarchy. The memory in a computer system is required for storage and subsequent retrieval of the instructions and data. A computer system uses a variety of devices for storing these instructions and data that are required for its operations. Normally, memory classifies the information to be stored on a computer in two basic categories: data and instructions. The storage devices, along with the algorithm or information on how to control and manage these storage devices, constitute the memory system of a computer. The memory system is a very simple system, yet it exhibits a wide range of technology and types. The basic objective of a computer system is to increase the speed of computation. Likewise, the basic objective of a memory system is to provide fast, uninterrupted access by the processor to the memory, such that the processor can operate at the speed at which it's expected to work. But does this kind of technology, where there is no speed gap between the processor and the memory speed, exist? Yes, it does. But unfortunately, as the access time becomes less and less, the cost per bit of memory becomes increasingly higher. In addition, normally these memories require power supply till the information needs to be stored. These things are not very convenient, but on the other hand, the memories with smaller cost have very high access time that will result in slower operations of the CPU. Characteristics, terms for various memory devices. The most commonly used terms for identifying the comparative behavior of various memory devices and technologies are: storage capacity. It is representative of the size of the memory. Unit of transfer. A unit of transfer is the number of bits read in or out of the memory in a single read or write operation. Access modes. The unit of transfer that is the next important characteristic is the access mode in which the information is accessed from the memory. Permanence of storage. Is it possible to lose information stored by the memory over a period of time? If yes, then what can be the reasons for the loss of information, and what should be done to avoid it? There are several reasons for information destruction. These are destructive readout, dynamic storage, volatility, and hardware failure. There can be some memories where the stored 1 loses its strength to become 0 over a period of time. These kinds of memories require refreshing. Cycle time. It is the minimum time lapse between two consecutive read requests. Is it equal to access time? Yes, for most of the memories except the ones in which destructive readout is encountered or a refreshing cycle is needed prior to next read. Cycle time for such memories is the access time, time elapsed when a read request is made available, plus writing time, as after the data has been made available, the information has to be written back in the same location as the previous value has been destroyed by reading. Data transfer rate. The amount of information that can be transferred in or on the memory in a second is termed the data transfer rate, or bandwidth. It is measured in bits per second. Physical characteristics. In this respect, the memory devices can be categorized into 4 main categories: electronic, magnetic, mechanical, and optical. One of the requirements for a memory device is that it should exhibit two well-defined physical states, such that 0 and 1 can be represented in those two states. Now we will study main memory. As the name implies, the main memory provides the main storage for a computer. Two CPU registers are used to interface the CPU to the main memory. These are the Memory Address Register, or MAR, and the Memory Data Register, or MDR. The MDR is used to hold the data to be stored and or retrieved in or from the memory location, whose address is held in the MAR. It is possible to visualize a typical internal main memory structure as consisting of rows and columns of basic cells. Each cell is capable of storing one bit of information. A word select line is used to enable all cells in a row for read or write. Because computers often have too little main memory to hold all of the data they need, computer engineers invented a technique called swapping, in which portions of data are copied into main memory as they are needed. Swapping occurs when there is no room in the memory for needed data. When one portion of data is copied into memory, an equal-sized portion is copied or swapped out to make room. The main memory is a random access memory. It is normally organized as words of fixed length. The length of a word is called word length. Each of these memory words has an independent address, and each has the same number of bits. Normally, the total number of words in the memory are some power of 2. Some typical memory word sizes are 8 bits, 16 bits, 32 bits, etc. RAM and ROM chips. A ROM chip does not require a constant source of power to retain the information stored on it, whereas a RAM chip does require a constant source of power to retain the information. Memory address map. Memory address map is address space that is assigned to each memory chip. For example, 512 bytes RAM and 512 bytes ROM. Memory connection to CPU. RAM and ROM chips are connected to a CPU through the data and address buses. The low-order lines in the address bus select the byte within the chips, and other lines in the address bus select a particular chip through its chip select inputs. Let's now learn the meaning of auxiliary memory. The auxiliary memory devices used in a computer system are magnetic disk, tapes, magnetic drums, and more recently, optical disks. The important features of any device are its access mode, access time, transfer rate, capacity, and cost. Magnetic disks. A magnetic disk is a circular plate constructed of metal or plastic coated with magnetized material. Magnetic tape. Magnetic tape is one of the older types of magnetic storage media. The magnetic tape recorder was invented in 1928 and was primarily used for analog audio recordings. Before music CDs were introduced in the 1980s, portable music devices used magnetic tape in the form of music cassettes. DVD, digital versatile disc. DVD drives are now widely available in computers as well as home entertainment centers. DVD-ROM drives can read data such as stored commercial videos for playing. DVD-RW allows DVDs to be created on a computer. The DVD is a flat disc, the size of a CD, 4.7 inches diameter and 0.05 inches thick. Associative memory is a storage unit of digital computers in which selection is performed not according to a concrete address, but rather to a preset combination of attributes, characteristic of the desired information. Such attributes can be part of a word, attached to it for detection among other words. Certain features of the word itself, for example, the presence of specific codes in its digits, the absolute value of a word, and its presence in a preset range, and so on. The operation of an associative memory is based on the representation of all information in the form of a sequence of zones according to properties and characteristic attributes. The retrieval of information is reduced to the determination of the zone according to the preset attributes by means of scanning and comparison of those attributes with the attributes that are stored in the associative memory. There are two basic methods of realizing the associative memory. Hardware organization. Compare each word in CAM in parallel with the content of A, argument register. If CAM word I equals A, MI equals 1. Read sequentially accessing CAM for CAM word I for MI equals 1. K, key register, provides a mask for choosing a particular field or key in the argument in A. Only those bits in the argument that have 1s in their corresponding position of K are compared. Read operation. By the help of read operation, access the content of data in memory unit. It is also the memory unit which storage locations are identified by their contents. This usually takes place in the hard drive. Write operation. Write operation allows a main memory block to be loaded in any cache memory line. The logic of control of the cache memory interprets a memory direction as a label in a word field. To increase the speed of a processor, the time for accessing the information is to be reduced. For this, a cache is used. The effectiveness of this cache is based on the property of programs called locality of reference. Analysis of the programs show that most of their execution time is spent on routines in which many instructions in localized areas of the programs are executed repeatedly. These instructions may constitute simple loop, nested loop, etc., and the remainder of the program is accessed not so frequently. This is referred to as locality of reference. There are two concepts behind the locality of reference: temporal and spatial. Temporal means that a recently executed instruction is likely to be executed again very soon. A spatial aspect means that the instructions very close to a recently executed instruction, cache block, cache line, are also to be executed soon. Memory organization of cache memory. CPU, central processing unit, is just like the brain of a computer and performs the arithmetic logical operations of the system by carrying instructions on the code. The memory organization